So now it's time for us to talk about AWS Route 53 routing policy. So the AWS routing policy or AWS Route 53 routing policy is a key feature of Amazon's domain name system. It allows you to manage how your internet traffic is routed to your AWS resources based on specific rules or algorithms. That's why it is called a policy. And we have a lot of them in line for us. So let's check them out. First off, we have the simple routing policy. Second, we have the failover routing policy. Third, geolocation routing policy. And the another one, that is something that you guys had already asked me a lot of times that I had missed out on the previous video about where is Geoproximity routing policy. We have the geolocation, but we don't have the geoproximity. So here it is. The next one is latency routing policy. We have the IP based routing policy as well. Next is also very interesting, that is a multi-value answer routing policy. And the last one, that is weighted routing policy. And don't worry, I'm not going to skip any one of these. I'll be discussing all of them. So let's get started. So the first one that we have here is simple routing policy. So with a simple routing policy, you create a DNS record for your domain name and specify the IP address or DNS name of your resources. When a DNS query is received for your domain name, Route 53 actually responds with the IP address or DNS name that you specified in the DNS record. And if the IP address or the DNS name changes, you'll simply update the DNS record to reflect the new value. So we have a list of information that you need to provide along with while creating a simple routing policy. So make sure that you check them out. And if you want to read along this, then please pause the video and go through this. It's really helpful. So here we have the routing policy, that is simple routing policy. The record name is basically this the name of the domain or subdomain that you want to create the DNS for. For example, we have Pythoholic.com or Flipkart.com. The value is basically the IP address or the DNS name of the resource that you want to route the traffic to. For example, it could be either 192.0.2.1 or example.s3.website -uswest2.amazonaws.com. Next is the record type. So this is basically like it specifies the type of DNS record that you want to create. So for simple routing policy, this will be A. For IPv4 addresses, for quadruple A, it will be used for IPv6 addresses. And there is one more important concept called TTL in seconds. So this stands for time to live and specifies how long DNS resolvers should cache the record before requesting a new one. And the value that we have here is in seconds and can be set to any value, but typically it ranges from a minute or a few minutes to a few hours. Okay, so these informations are a bit elaborate, but let's understand this concept of TTL, which is very important. So TTL or time to live is a value that is set for each DNS record to specify how long the record should be cached by DNS resolvers and other DNS servers before it expires and needs to be refreshed. Here we all are trying to connect to Pythoholic.com. It reaches the resolver with the cache. Then it reaches the authoritative server for resolution. Here each of the user gets a response back, but the third user gets a new IP. Because of time to live. Here you can see with the 0th minute, www.pytholic.com resolves to 162.35.221, 22.1. So when the user actually sends the request, pytholic.com, the resolver actually sends the request to the authoritative name server. And once it gets the IP back, it actually caches it for 30 minutes. And it sends the response to the user, that is the same IP address that it collects from the authoritative name server. That is basically your 162.35.22.1. Similarly, this is what happens for the second user, which actually requests for the website within 15 minutes. And the next one or the last one that we have here is the user that actually exceeds the 30-minute threshold. And that is why the IP actually has changed during that time. So it actually sends the new IP address to the third user. And that is what is time to live. So time to live is value that is set for each DNS record to specify how long the record should be cached by the DNS resolver and other DNS servers before it expires and needs to be refreshed. And 30 minutes is basically a huge amount of time considering the availability of the servers. Like you might have a doubt, like what happens if during that period the server is not reachable anymore and it is trying to just provide the cached value to every user that comes along. So in this case, if the server IP specified in the DNS record is not reachable or has changed during the TTL or the time to live period, then the DNS resolver may continue to use the cached DNS records until the end of the TTL period. And that's a bad thing, isn't it? Which could cause issues for clients trying to access the domain. So for example, let's say you have a DNS resolver cache with a record with a TTL of 3600 seconds for a domain name that points to a specific IP address. So if the IP address becomes unreachable or changes during the TTL period, the DNS resolver may still return the cached record to the clients, even though it is no longer accurate. To prevent issues like this, yes, that's one thing that is really important. We want to prevent this. So it is important to regularly monitor the availability of your servers. And you must update your DNS records as needed, including adjusting the TTL value as well. So you must always try to shorten it if necessary, because that will actually help users to have a valid response every time they visit the website. So now that you are aware about TTL, let's move on to the second one, that is failover routing policy. As it is mentioned here, failover routing policy lets you route traffic to a resource when the resource is healthy, or a different resource when the first resource is unhealthy. So imagine this is you and you entered the URL and it goes to the AWS DNS. Here we have a region A where the instance is available to us. If the health check is successful, then the request will be what? The request will be routed to that instance as it is the default. Else it will move to the failover instance in the case of health check failures. That is why it is called the failover routing policy. Here as well, the information that you need to create the policy are provided here. But as we can see, we have 3 new entries. One is the failover record type. So basically it works like this. So when you visit a website, your computer sends a request to the DNS server to get the IP address of the website server. So normally the DNS server just sends back one IP address and your computer connects to that server to get the website content. But with a failover record type, the DNS server sends back multiple IP addresses, each one representing a different server. So the first IP address is for the primary server, the one that should be working normally. But if something goes wrong and the server actually stops responding, the DNS server automatically sends back the IP address of the backup server instead. So this happens without you even knowing it, and you can keep using the website or service as usual. The next one is health check. So we select a health check if you want Route 53 to check the health of the specified endpoint and to respond to DNS queries using records only when the endpoint is healthy. So we have already discussed health checks before. This is no different than what we have already discussed, so don't worry about that. And the last one that we have here is record ID. So this basically is the value that uniquely identifies the primary and secondary records, and that basically is used for distinction. So where to actually route? So we need records, right? So the record IDs are also present. Now the next one is geolocation routing policy. So geolocation routing policy is a fancy name or fancy term for a cool way to make websites faster for people all around the world. Basically it works like this. So when you visit a website, your computer sends a request to the DNS server to find the website's address. And with geolocation policy or routing policy, the DNS server can find or figure out where you are in the world based on your IP address, and then redirect traffic to the server that's closest to you. So this means that if you are in Europe and you want to visit a website that uses a geolocation routing policy, you will be directed to a server in Europe rather than the one in United States or Asia. By doing this, the website can load faster for you because the data doesn't have to travel as far. So here we have a user in India and another user in US. Here we create a record for the instance at AP South 1 region and another one at US West 2 region. So when the user in India tries to reach the instance, the record directs it to the closest instance, hence making it easier for the users to get the resource. And similarly, if you are in US, it will redirect it to the record that is nearest to you, that is in US West 2 region. So here as well, we have a list of information needed to create the geolocation routing policy. Along with these, we have the most important thing, that is the location. So you need to specify the region or continent or the country for which you want the Route 53 to route the traffic. So this is simple. Now let's talk about the most important one that everyone was talking about, that is geoproximity routing policy. So imagine you are out for a trip to a new place, but you know a few people here, but you are a bit strange in this location. So you have John, Shahrukh and Deepika. No, you're not in the Pathan movie, don't worry. But now, after traveling for a long time, you're tired and you have to go to one of these friends to get some rest. Let's see. So from the place that you are right now, John's house is 100 meters away. Shahrukh's house is 200 meters away. And Deepika's house is 150 meters away. Now you need to decide where you want to go. The obvious option would be John, as he is the closest. That is the best option. You know that John is basically stupid and Deepika is a better friend. And you decided that you want to go to Deepika's house because she is a better friend. And in general terms, we call this with a particular term, which is, yes, it is a bias. So we are biased towards Deepika because we feel that she is a better friend. Remember this word bias. It'll be. So geoproximity routing is a type of DNS routing policy that sends website visitors to the servers closest to their physical location. It's like a GPS for the internet, helping websites load faster and reducing latency. But before you actually put into your head like, okay, geolocation routing is also the similar one, like it is similar to this, it's just the same because this also routes it to the nearest location. But hold on to that. I told you about the word bias, so that's what will help us understand the difference. So bias in geoproximity routing is used to prioritize certain locations over others when redirecting or when directing website visitors to a closest server. So this can be helpful when some locations are more important than others, such as directing traffic to the server with higher capacity or faster response times. And bias actually allows website owners to customize their routing policy to meet their specific needs and improve the overall user experience. And by reading this, you might be thinking, what is bias, shrink, or expand? So don't worry about it. We'll talk about this. So when you're driving to a destination using a GPS, you can choose different routes to get there. Similarly, in geoproximity routing, and bias is like choosing a preferred route to a server based on certain criteria. So for example, imagine you are driving to a friend's house, but there are two possible routes you could take. So one route is shorter but has a lot of traffic lights, while the other one is longer but has fewer traffic lights. So if you really want to get to your friend's house quickly, you might choose the longer route with fewer traffic lights, even though it is not the closest route. This example might fit in other countries, but in India, especially in Bangalore, you can't skip the traffic. So any route that you take will take a longer time. Okay, now let me break the ice here. So bias is nothing but a value. When it expands, it's a positive value between 1 to 99. That's a positive value, 1 to 99. But you might ask me, I saw the bias to be from 0 to 100. So value range of bias in geoproximity routing is typically between 0 and 100. Yes, a bias of 0 means that all locations are treated equally and traffic is directed solely based on proximity of the server. And a bias of 100 means that the preferred locations are prioritized to the maximum possible extent, and the traffic is directed only to those locations even they are not the closest. So in practice, the most important or most common bias values used in geoproximity routing are between 1 to 99. When it expands, that's the positive value. Now when the bias actually shrinks, it will obviously be a negative number between -1 to -99. The negative bias shrinks value or negative bias shrink value means that the preferred locations are narrowed down to a smaller area around the ideal location. So the absolute value of the bias shrink determines the size of the area. For example, a bias shrink of -10 would create a smaller area around the ideal location than a bias shrink of -5. Okay, so I hope you got the point here. Then let's take an example. So this is a region map, and let's start off with the bias value of ±0. So this is a zero biased map. So there is no bias. The request will go to the nearest resource that's available. So it could go to any of these locations, 1, 2, 3, 4 or 5. Let's give expand value or expand bias to US East region, North Virginia, which is the number 2 in the map. So here you can see when we added a plus 25 bias, so now the traffic is routed to the resource in that region from the larger portion of North America than it was previously there, and from all of South America. So previously, as you can see here, this was a narrow zone, and we increased the bias of plus 25 for US East North Virginia. You can see there's a lot of region that has been covered here. So we are trying to be biased towards North Virginia by increasing the bias with a positive value and expanding this. Now what happens if we shrink that? So let's suppose we shrink it to minus 25. So change the bias to minus 25 for the US East North Virginia region. So here, as you can see, the traffic is routed to the region in that particular region from a smaller portion of North America or South America than previously, and more traffic is routed to the resources in the adjacent regions, like it could be 1, 3 or 5. And this is how you can visualize the bias. And remember, to use geoproximity routing, you must use Route 53 traffic flow. Remember this. For geoproximity routing, you should use Route 53 traffic flow. Now let's do some calculations to understand this better. So here is a source of query or source of the query, like the origination of the query. And we have a resource that we can access, and it's 150 kilometers away. And another one that we have here is just 100 meters or 100 kilometers away. So basically, when you see this, the most obvious option for us to choose is like web server B, because it is 50 kilometers lesser than web server A. So that's a genuine choice, isn't it? Now let's see the effect of bias in this. So a positive bias distance is the actual distance multiplied by 1 minus bias value by 100. So this is the positive bias. So bias distance is equal to actual distance multiplied by 1 minus bias by 100. The negative bias is basically your actual distance divided by 1 plus bias by 100. So when we have the value of the bias that is positive, Route 53 treats the source of the DNS query and the resource that you specify in geoproximity as if they were closer than they really are. So let's suppose you're looking into the rear view mirror and the objects are closer than they appear, isn't it? Because there is a bias in the lens. So we have a record A for web server A, which has a positive bias of 50. So here the web server A has a positive bias of 50, and record B here, or web server B here, has no bias at all. So now let's see the calculation here. So the bias is 50. The bias distance is actual distance multiplied by 1 minus bias by 100. So bias distance for the web server A, as the actual distance is 150 kilometers. So 150 kilometers multiplied by 1 minus the bias value, that is 50 by 100, which is obviously 150 multiplied by 1 minus 0.50. That is basically 0.50. So 150 multiplied by 0.50 is 75 kilometers. So now, as you can see here, so now based on our calculations, if the record has a positive bias of 50, then we'll think it is only 75 kilometers. So for the query, the 150 kilometers is just 75, and compared to 100, the 75 looks closer. So it goes to the resource which is located 150 kilometers away, even though in reality it is the farthest one. So now you see the importance of bias. It can actually trick you into thinking that the resource is closer even if it is not. So you might say, what's the advantage here? Why are we doing this? So for example, a website owner wants to direct traffic to a server that has more available capacity or is better optimized for a certain type of request. So even if it is not the closest one, by using bias, they can prioritize that server over others and ensure that traffic is directed to it as much as possible, while still taking proximity into account. So that's a very beautiful concept, and bias is something that is a really interesting subject. And I would suggest you to please go to the website and the documentation and read more about this. This is really interesting. Now we come back to the latency routing policy. This is one of my favorites. So let's, for our imagination, if you are in New York and you're visiting a website that has a server in both New York and California, the website will automatically direct you to the server that has the fastest response time, which is probably the one in the New York location. So this means you'll get a faster and more enjoyable experience on the website. So latency based routing is very helpful or really helpful for websites that have a lot of global traffic and needs to ensure that visitors have a good experience no matter where they are in the world. It's like magic tool that makes the internet faster and more reliable. Here as well, if the user is in India, it'll reach the one that's closer. Here we have one server that is in AP South 1. So based on the routing based policy, it'll reach AP South 1 location. But if suppose there is another one that is closer to this or than this, then it will be redirected to that. But in case if you don't know what latency is, so latency is the amount of time it takes for a data packet to travel from the sender to the receiver and back again. In other words, it's the delay that occurs when the data is transmitted over a network. So for example, if you're streaming a video from the website, latency would be the delay between you clicking the play button and when the video actually starts playing. If the latency is high, it may take several seconds for the video to start, which can be very frustrating for the users, isn't it? So in the context of latency based routing, the focus is on finding the server that is closest or which can provide the lowest latency for the user, which helps to ensure a faster and more reliable user experience. And here as well, we need to provide information to create the latency based routing. Along with these already known parameters, we have a new one, that is the region. Yes, you need to provide the Amazon EC2 region where the resource that you have is, or the resource that you have in this specific record resides. So you can also create one latency record for each Amazon EC2 regions. You aren't required to create latency record for all Amazon EC2, but that's a good thing. And let's move on to the next one. This is also a very interesting one, which is IP based routing policy. Yes, the IP based routing policy is a method to direct traffic or network traffic based on the IP address of the sender or receiver. So each device connected to a network is associated or assigned a unique IP address that we all know, which can be used to identify the device and route traffic to it. So when data is sent between devices, routers use the destination IP address to figure out where to send the data next. Think of it like a postman who reads the address of a letter to figure out where it needs to be delivered. But the amazing use case for IP-based routing is basically like it is used in big networks, like in large offices or schools, to make sure data is sent to the right place efficiently. So it's like a traffic controller, making sure that each car on the road is going to the correct destination. So how it actually works is, let's suppose you have a user here, which has the IP address of 203.0.113.5. Here, the IP-based routing policy will try to match this IP address to a matching CIDR block. That is 203.0.113.0/24. And the user will be directed to this resource itself. So in turn, you can say that it is matching the query IP to the CIDR of the resource. And thus, the user is directed towards that resource itself. So that's how it works. So let's suppose you have something that is matching for this CIDR block, then the user will be redirected to this particular resource. Now that it matches this CIDR block, so this user gets redirected to this particular resource block. That's how the IP-based routing works. Now it's time to talk about the multi-value answer routing. So multi-value answer routing in Route 53 is a feature that allows you to route traffic to multiple resources based on the routing policies you specify. So this means that when routing or Route 53 receives a DNS query for a domain name, it can respond with up to 8 different IP addresses, which are assigned to different resources such as EC2 instances or load balancers or S3 buckets. So with multi-value answer routing, you can improve the availability and performance of your application by distributing traffic across multiple resources. So if one of the resources becomes unavailable, actually Route 53 can automatically redirect traffic to other available resources. And this can also help you, achieve higher availability and reduce the risk of downtime. So let's suppose you are a user here and wants to access the resource using the URL www.pythoholic.com. Now with multi-value routing policy, the DNS server will return it with multiple IP addresses for the resource. And based on the factors like availability, health check, it'll help you reach the destination. But you might think, how does it choose among several IP addresses? So Route 53's multi-answer routing policy uses a round-robin method to distribute traffic among the available IP addresses. So this means that when a Route 53 receives a DNS query, it responds with a different IP address each time, cycling through the available options in a circular pattern. So this way, traffic is evenly distributed among the available resources. Additionally, Route 53 can use other routing policies as well, such as latency-based or weighted routing, to choose the best available resource based on the factors like geolocation or geographical location or performance matrices. As rightly mentioned here, if you associate a health check with a multi-value answer record, Route 53 responds to DNS queries with the corresponding IP addresses only when the health check is healthy. Yes, if it is healthy, and if you have associated it to the record, then it will check whether it is healthy and it will return that if that is healthy. So if you have 8 or fewer healthy records, Route 53 responds to all DNS queries with all the healthy records. When all records are unhealthy, Route 53 responds to the DNS queries with up to 8 unhealthy records. So overall, this gives multiple answers. That's the gist. And here it is, and this is how it looks like. So here you can see we have 3 entries of a record here for pythaholic.com with 3 different health checks, A, B, C, and that's what the DNS returns. And remember, you can have up to 8 such entries. So we have the name, the record type, the value of the IP address for the given record, the time to live, 60 seconds, set ID, and the health check. And remember, if you don't associate a health check with a multi-value answer record, Route 53 always considers the record to be healthy. So that's something that you need to be careful about. Now, the last one is weighted routing policy. So when it comes to the next one, when it comes to weighted routing policy, which is also very interesting, the weighted routing policy is a feature of Route 53 that allows you to distribute traffic to multiple resources in a way that's based on weights or percentages that you specify. So for example, let's say you have 2 resources, resource A and resource B, and you want to distribute traffic between them. With weighted routing policy, you can assign a weight or percentage to each resource, such as 70 for resource A and 30 for resource B. This means that for every 100 request, 70 would go to resource A and 30 would go to resource B. And the weight distribution is computed as weight of the specified record divided by sum of the weights of all the records. So now based on that, let's see this. So we have the value A. Let's suppose the value A is 1 and value B is 255. So weight A will be weight for the specified record by sum of the weights of all the records. That is 1 by 256th of traffic. The weight B will be the value, that is 255 by 1 plus 255. So let's suppose you have 100, then it will be 100 by 256 and 156 by 256. 0 will be 50%, 50%, and 0 to 56 will be 0 and 256. So when we say 1 by 256 of traffic, it means that, so 1 by 256 of the traffic will be gone to the value A or the server A, and 255 by 256 of traffic will be gone to weight B. So that's how it is computed. And here as well, we have the parameters needed to create the weighted routing policy. But the most important parameter here is, yes, the weight. So the weight is the value that determines the proportion of DNS queries that Route 53 responds to using the current record.
Subscribe to the Pythoholic YouTube channel for awesome content, and it's completely free because we believe the best time to start learning is right now.